Hey guys, today I'll be giving you a brief introduction into the topic of elastic and plastic deformation. The key topics that we will be discussing today are elastic deformation, Hooke's law, modulus of elasticity, Poisson's ratio, plastic deformation, yielding, tensile strength, ductility, and resilience. Elastic deformation is the range of strain in which, when released, the material returns to its original state. The degree to which a structure deforms or strains depends on the magnitude of the imposed stress. Elastic deformation is non-permanent. Stress and strain in an elastic form forms a linear relationship, as can be seen on the graph. Hooke's law. When materials are stressed in tension at relatively low levels, the stress and strain are proportional to each other, as seen in the formula of Hooke's law. Young's modulus is the modulus of elasticity. The slope of the line plotted using Hooke's law corresponds to Young's modulus. The greater the value of Young's modulus, the stiffer the material is. Constrictions perpendicular to elongation caused by the applied stress will form when elongation happens. These constrictions or strains can be found if the applied force is acting in only the one axis using Poisson's ratio. Perpendicular constrictions can be shown in the diagram. Plastic deformation occurs when a material is deformed past elastic deformation. Plastic deformation is permanent, and the stress is no longer proportional to strain. Yielding is the point at which the transition from elastic to plastic deformation occurs. It is found by determining the point at which the stress-strain curve is nonlinear. The yield point is important to know, because most structures are designed so only elastic deformation occurs, and structures that have deformed past this point may not be capable of functioning properly. Tensile strength is the point at which uniform deformation ends, and it is found by the maximum point on the stress-strain graph. After this point, necking occurs until fracture. Ductility is the degree of plastic deformation that has been sustained at a fracture. Can be expressed as either percent elongation or percentage reduction in area. Resilience, the capacity of a material to absorb energy when it is deformed elastically, and then upon unloading to have its energy recovered. The modulus of resilience is the strain per unit volume required to stress a material from an unloaded state to the point of yielding. Thanks guys for listening to my presentation.